Okay, so today's lesson is 1.2 factoring polynomials. So let's start right into an example. That's the easiest way to talk about the remainder theorem, which is coming up. So that we have a polynomial. We have p of x equals x cubed minus 4x squared plus 5x minus 1. And just remember that p of x is like a y. So what does it mean when we put a p3 in there? P3, well, we replace x, this thing here, with 3. So that means in the equation, or sorry, in the polynomial, we replace every x with a 3. So we just plug it in, right? So 3 cubed minus 4 times 3 squared plus 5 times 3 minus 1. And then you just do the math, and you end up with 5. So when x is 3, it returns a value of 5. So for instance, like if x was 3, y would be 5. And you could graph that if you needed to. Okay? So then look at this one here. So we have find the remainder for the division of this one. So here's our polynomial, and we do synthetic, so we look at the coefficients, right? So 1, negative 4, positive 5, negative 1, write that across the top. We have divided by x minus 3, our divisor, right? So what do you plug into this to make that equal to 0? Well, you plug in a positive 3, so the 3 goes out the front. And then you do all the work. Bring down the 1. 3 times 1 is 3. Add those together, you end up with negative 1. 3 times negative 1 is negative 3. Add those together, you get 2. 3 times 2 is 6. Add those together, you get 5. Oh, wait a sec. You get a remainder of 5, but if you look up here, when we plugged in 3, we also got a 5. Well, that's kind of cool. So the calculations for example 1 and 2 are very different, but the remainder theorists tell us they always give us the same answer. So this is just a fancy way of saying if you plug in a number and you end up with a remainder of 0, then you know that what you plugged in was a factor. So back up here, this x minus 3, is it a factor? No, because we ended up with a remainder of 5. If we plug this in and did it and we end up with a remainder of 0, hey, that is a factor of that polynomial. So it's a fast way to tell us whether or not it's a factor. Okay, flip the page, go to example 3. So we have this big long one here. We got x to the 4 minus 9x squared minus 2x plus 5. Ooh, look, it's missing the 3 in there. Be careful. Find p of negative 3. So we could do it by substitution. You just plug in negative 3. So wherever there was an x, plug in negative 3, do all the math, you end up with 11. Okay. Or you could use synthetic division. Now, synthetic division, you got to be careful. We were missing the x cubed, so we need to have that 0 in there. So we do all the coefficients, 1, 0, negative 9, negative 2, 3. We're plugging in the negative 3 here. We end up with the same remainder of 11. So is that a factor of that polynomial? No, because we end up with a remainder of 0. Okay. Now, look at this one. Is x plus 1 a factor of, oh boy, x to the 15 minus 3x minus 2? Now, can you imagine doing this as synthetic division? It'd be ridiculous to do all this because you'd have like a 1 and then a 0, 0, 0, 0, 0. You got a whole stack of zeros in there. So we can do binomial remainder theorem. So plug in negative 1, right? Because we're plugging in what makes this equal to 0, which would be negative 1. We plug it in, so negative 1 to the 15 minus 3 times negative 1. Now, negative 1 to the 15, you know, it's a negative, and that's an odd exponent. You know your answer is going to be negative, right? We learned that back in grade 9. So we plug in 0, and we get a remainder of 0. Oh, cool. So since the remainder is 0, by the factor theorem, x plus 1 is a factor of that thing. Oh, that's kind of cool. Okay, example number 5. So factor x cubed plus 6x squared plus 11x plus 6. So this is the first one where we're actually going to factor it into a bunch of binomials. Well, the problem is you don't know what one of the factors are. So we tried the easy one. So what we're going to do is we're going to substitute values into the polynomial until you find one that gives us a remainder of 0. So look at the last one. We got a 6 here at the end, right? So what are we going to try? We're going to try 1, 2, 3, and 6 because those are all factors of that. Now you could also do the negatives to go with it, but let's plug in. So let's try 2. So we try 2, p of 2. So plug it in, right? Replace all the x's with 2. You find out, no, wait, doesn't equal 0. So you could stop because you can see these are all addition. You know there's no possible way it could equal 0. So that is not a factor. Okay, let's try negative 1. So we plug negative 1 in. Where we see an x, plug in negative 1. We do all the math. Oh, look, we end up with a remainder of 0. So we know, therefore, the 3 dots there, that x plus 1 is a factor. Right? Remember, because we tried negative 1, so there's our binomial. Okay, so now let's go do synthetic division to help us here. So we do 1, 6, 11, 6. Remember, those are the coefficients. Coefficients of way up here, 1, 6, 11, 6. Yeah, we plugged them in. We know negative 1 should work. We should end up with a 0. So we bring it down, multiply, add, multiply, add, and we end up with our remainder of 0. Now, this 1, 5, 6, what does that tell us? Well, we know that the original one was an x cubed, like a cubic, so we know it has to be an x squared. It's one less down. So it's x squared plus 5x plus 6. Now, this should look familiar. This is back in grade 11 when we had trinomials and we factored them. So this one here factors into x plus 3 and x plus 2. But don't forget your original one, the x plus 1. We end up with 3 binomials. And that makes sense because when we multiply all this together, we're going to get our x cubed, right? The x times the x times the x. So those 3 binomials right there are factors of that whole polynomial there. Now, this is an x cubed one. We're going to do x4s and x5s, but the process is still the same. Use binomial remainder theorem, plug in numbers, find ones that equal 0, then do synthetic division, and find your trinomial, and then you can factor into 2 binomials. Okay, so that's 1.2. There's another quick lesson after this. It's the polynomials extra practice. You can see it right away. Save this.